horizontal pipe of cross-sectional area 5 cm square connected to a venturimeter of throat area 3 cm square as shown in the figure. The manometer reading is equivalent to 5 cm of water. The discharge in centimeter cube per second is nearly. Here we'll have to find out the discharge in the pipe. So here we use a venturimeter of cross-sectional area 5 cm square and 3 cm square throat area, and here is the options 0.45, 5.5, 21.0, 370 centimeter cube per second. Here first write down the given data. Let us say the pipe cross-sectional area is A1, that is 5 cm square, and throat area is A2, which is 3 cm square, and the reading of the venturimeter manometer is 5 centimeter of water, that is, let us say H is equal to 5 centimeter. So the discharge through a pipe is given by A1 A2 root 2GH by root of A1 square minus A2 square. So substitute all these values in the given equation, that is Q is equal 5 into 3 into root of 2G into G is 9.81 meter per second square or 981 centimeter per second square into H is equal to 5 centimeters by root of 5 square minus 3 square, and is equal to the value 37.1 centimeter cube per second. So here the right answer is 37.1 centimeter cube per second, and in the option the correct option is D. Sorry, it is 37.1. So in the option the correct option is D. D is the right answer. Here it is a question of assertion and reason. Here the assertion is Nusselt number is always greater than unity, and the reason is Nusselt number is the ratio of two thermal resistances. One thermal resistance which would be offered by the fluid if it was stationary, and other thermal resistance associated with convective heat transfer coefficient at the surface. So here the in the assertion Nusselt number is always greater than unity, but we don't have any proof for the Nusselt number is always greater than unity. But coming to the reason, it is a ratio of two thermal resistances, one associated with fluid and other associated with convective heat transfer, and it is correct. So here assertion is false and reason is right. So here the right answer is D. Here the correct option is D. Consider the following refrigerants. Those are freon 12, freon 22, carbon dioxide and ammonia. The refrigerants in order of increasing boiling points are, here the options are 1, 2, 3 and 4, 4, 3, 2 and 1, 2, 3, 1 and 4, 3, 4, 2 and 1. Yeah, coming to the boiling points of different refrigerants, here carbon dioxide has the lowest boiling point temperature and freon 12 has the highest boiling point temperature. So in the options, the D is the right answer. So correct option is D. The materials in ascending order of their yield strength. Here the options are brass, bronze, steel, copper, brass, copper, steel and bronze. So in these options, the correct option is D. Here the yield strength increase in order of their yield strength, brass, bronze, copper and steel. A 10 mm thick brass alloy strip is rolled by using steel rollers of radius 80 mm. The yield strength of the brass is 250 megapascal and coefficient of friction between the workpiece and the rolls is 0.3. The maximum possible change in thickness in rolling process is, here the options are 2.8 mm, 7.2 mm, 7.6 mm and 4.4 mm. So here the maximum possible change in thickness in a rolling process is given by, so initial thickness minus final thickness is equal to the maximum possibility is mu square into R, where R is the radius of rolls. Here mu is given by 0.3, that is the coefficient of friction between the workpiece and rolls, and R is equal to the radius of rollers, that is 80 mm, which is equal to 0.09 into 80 or 7.2 mm. Here the right answer is 7.2 mm, and in the option the correct option is B. B is the right answer. Of 20 mm diameter and 500 mm length is to be drawn into a final diameter of 5 mm. The minimum number of drawing passes required will be, here the options are 5, 4, 3 and 2. So generally in a single pass the maximum reduction of possibility is equal to, let us say, the final area cross sectional area is AF and initial is AI and the maximum reduction in area is equal to 0.37 AI, that is 0.37 times initial area, or we can reduce 63% reduction. So it is equal to 0.37 into AI and is equal to, let us say, after the first pass A1 is equal 0.37 into A initial diameter, that is pi by 4 into 20 square. So which is equal to 116.23 and D1 is equal to 12.16. So here the after the first reduction the final diameter is 12.16 mm, but here it is to be drawn into a final diameter of 5 mm. So go for the next pass, that is after the second pass D2 is equal, let us say after the second pass A2 is equal to 0.37 times A1, that is pi by 4 D2 square is equal to 0.37 pi by 4 D1 square. So here D2 comes from this equation and is equal to 7.4 mm, and again it is greater than the final diameter of the wire, that is 5 mm, and again go for the third pass. So after third pass D3 is equal to, again root of 0.37 into D2 and is equal to 4.5 mm. So it is less than the 5 mm, so that the minimum number of passes required is 3. So here 3 passes are required to reduce to the 5 mm. So here in the option, the correct option is C. C the right answer.